You might be wondering how integrals are practical. Quick rundown. Integrals are practical when you're wanting to find the area under a curve. I'm going to get a little bit advanced here for just a second. If I want to know that area, I can use a definite integral. This is a definite integral because I definitely know the limits of it. If I did not have that, it would be an indefinite integral, and all we could do is just find an expression for it, but we would not be able to actually evaluate it. So this gives us the area, which tells us the quantity. I'm going to ramble for a second. If I have a graph of some sort of rate, if I have a graph that graphs miles per hour, then finding this area doesn't tell me miles per hour, it tells me miles, which is very practical. Knowing rate can give you the actual antiderivative quantity. If we know how many cars per minute go under a traffic light, and we can graph that cars per minute rate, then finding the integral will tell us exactly how many cars. Not cars per minute, but it will tell us cars. Okay, I'm going to go off the deep end for just a second. Allow me to go there. In advanced calculus, because I've always wanted to get to this topic in honors calculus, and I've never had a chance, and I honestly obviously didn't this semester either. There's this really cool idea where you can find the volume of a solid by rotating it around an axis. And part of that involves an integral. Let's suppose we have some graph that does this, and I want to know what the volume of that shape would be if I rotated it around the axis. In other words, if I was to take it and kind of rotate it and flip it around like that, and we would have this funky looking thing like this. My goodness, if I could draw, it'd be dangerous. We're going to have this thing, and it's three-dimensional. It's kind of rounded, kind of goes around like that. It's sort of hard to visualize because I can't draw. Don't tell Mr. Lapina. We'd have some sort of rounded, crazy-looking thing like that, and using the integral with another special formula is going to tell us what that volume is, and that's incredibly practical when they're manufacturing certain items, round items, things that go in a car. Tells you the volume, tells you how much metal you're using. So all the stuff we're doing leads to some amazing, fantastic, very practical stuff that I didn't get a chance to cover. Ah, dang it. Okay, enough of my grief and the fact that math is cool and I didn't get to it. We're going to find the value of this definite integral. We're going to do this one by hand using the fundamental theorem of calculus. Fundamental theorem of calculus is this. If I want to know a definite integral, I can take the antiderivative and subtract upper limit minus lower limit. There's a fancy way of writing it, but it basically comes down to this. The antiderivative of 4 cosine x is going to involve a sine, and because there was a 4 here, there better be a 4 here. The derivative of this is that. Awkward notation. Negative pi over 2 to positive pi over 2. What's about to happen is we're going to plug pi over 2 in, plug negative pi over 2 in, crank out 2 separate answers and subtract them. Again, fundamental theorem of calculus basically says antiderivative with that plugged in, antiderivative of that plugged in, it'll tell us this value. It'll tell us its sweet secrets. 4 sine, oops, turn that to a pi somehow. That's what the guy said when he was baking a cake. That was pretty dumb, wasn't it? Yeah. Okay. Anyway, minus 4 sine negative pi over 2. Okay, this is how you do it by hand. Sometimes you'll have to do these things by hand. So, sine of pi over 2, that's 90 degrees. Sine of 90 degrees is 1, so we really have 4 times 1. That works out pretty well. Sine of negative pi over 2, that's negative 90, or 270. Unit circle in my head right now. If I could zoom in far enough, you could see the unit circle in my head. It's not that kind of camera. So 270 is negative 1, so we have 4 times negative 1, that's negative 4. 4 minus negative 4, the answer is 8. And you can check that in your calculator using the method I'm about to show you for the second one. Okay. There is more than one way to do this on the calculator. I'm going to show you just one of the methods. So when we do this, I know I told you earlier we need to simplify first, but we're not going to. 2x squared minus 4, and it's squared, and then 4x dx. Now, if we were doing this by hand, we'd have a bunch of foiling and distributing to do, and we're not going to mess with it. We're not. Because there is a shortcut in the calculator, because let's be realistic, we live in age technology, and these things can happen for you. The reason I make you do some of them by hand is so you can understand the concepts behind it. Nevertheless, technology exists to where you don't have to do them all by hand, thankfully. So, I'm just going to write down the steps that you would do in the calculator. I'm sure you'll be able to follow. There's a thing under the math menu, so you press math. And for most of the calculators, it's number 9. For some, it may not be. But it's fn int. It's the function integral. You'll choose that one. If you have one of the newer calculators, the black calculator, it's going to set it up to where it looks like this. And in that case, you just type what you need in the correct places. Otherwise, you'll keep going with this. The first thing you're going to type is the function, comma, x, because we're anti-differentiating with respect to x, comma, the lower limit, comma, the upper limit. And then we'll close out our parentheses. Parentheses automatically popped up when we hit that one. So for this particular problem, we're going to type math, function integral, and your calculator is going to start looking like this. And then you're going to type all that mess right there. So parentheses and all, 2x squared minus 4 squared 4x. You might be way ahead of me on this. That's okay. Comma x, comma, -1, comma, 2, close parentheses. Grab my calculator, we'll type this in, we'll compare it. We have 2x squared. At this point, you're probably done and waiting on me to verify your answer. You're going to have to wait another minute because I'm not quite there yet. 9. We type in our function, comma x, comma, -1, comma 2. There we go. I got an answer. What'd you get? 24? Yeah. I've heard that was a good TV show. I never watched it. I'm going to ramble for just another second and show you something. Actually, I didn't type that in my calculator, and I want to show you what I typed. I just think it's kind of cool. Okay. Hopefully you can see this. If you will press y equals and type your function in, and then when you go out, you can do math, go to number 9, and then hit vars. See where my thumb is right there? Vars. And then hit enter on function, and then y1. That way, if you have to do the same function over and over, you don't have to type it over and over. It's stored as y1, comma, x, comma, -1, comma, 2. There we go, 24. That was it.